we're recording now. And now we're going to start this up. So we're in section 1.2, and I actually got my own little book here with me, but it's totally blank. So I don't have the answers still, and that's okay. I talked to one of the professors, actually like the statistics professor upstairs, and I said, "Hey, some of these are like kind of hard sometimes, and I can't tell which one is what." And she's like, "That's normal." She was like that. This is the fun part for her, where there's not a definite answer, and I'm just a math guy. I want to solve for x. I just want x equals 5, and so it's kind of weird, but we'll get through it. Some things though, and I've been reading through this a couple times today, just so I'm ready. Sampling error is actually a pretty important definition, and the main thing is this natural variation in results selected from a blah 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 blah. So later on in the homework, they're going to say, what is a sampling error? It's just going to be like a homework problem. You click that answer and you move on. So sampling error, natural variation. They're also going to talk about bias, and that's going to be a big part of what we're going to talk about here, bias. And so bias is just when things are what's another word for bias? It's not. Not fair? Maybe not fair. It's not what it should be. So we'll be seeing that a whole lot. Insufficient sample size is actually pretty important. If you got a smaller sample, things don't make sense. So here, I'm going to take a survey, okay, for the whole class, and I'm only going to ask. Hello. I'm only going to ask. I'm only going to ask one person. Do you like pizza? There it is. Nobody likes pizza. There it is. Nobody likes pizza. Does that make sense? That doesn't make sense. So that's that insufficient sample size stuff. Make sense? Okay, cool. So we'll see these as we keep going. So which of the following are bias? And they're going to change this up on you because one time they'll say not bias, and all of a sudden it's going to be totally different. So let's go through it. It says, which are bias? To estimate the presidential candidate who will win of a town, this is kind of important here, Mark collects data by interviewing people leaving a local church. So is that bias? Yeah? Because why? Sure. You're going right outside where one kind of one type of people are all thinking the same way. It's not like Walmart, let's say. Walmart would be a little bit more, broad. So yes. So is this biased? Yes. So I would circle it. Okay. Again, they're going to ask for not bias on the next question here in a second. Okay. And sometimes they're going to say town versus something else, and I'll show you in a second. Okay, so Kenneth wants to estimate the mean number of height in his school. He collects data from a random group in his classroom. So is that bias? You say no. Anybody say you say no? You say it's fine? Here's an interesting thought, and I'm thinking y'all are fine with this, that it's not bias. But what I'm thinking, what if that classroom had all the basketball players in it? Now all of a sudden the mean height looks a lot different, correct? Pretty interesting, right? So is it bias? I don't know. That's actually a pretty interesting question. Hello. I'm going to put a little tilde next to it because it doesn't seem biased at first, but then as soon as I mention basketball team, then all of a sudden it could be, right? Because there would be a lot taller and changed everything else and whatever. Okay, so estimate the male and female ratio in a city. Again, these are kind of important words. They collect data by recording every 50th person on the list. Every 50th person. Is this bias? No, it doesn't seem biased. Basically, you're going down the phone book, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check that person. Da 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 da. It seems fine. So is that bias? No, so I'm not going to circle it. Okay. Amy wants to estimate the mean grade point average of students in her school. So she collects data by recording every 25th person on the list. Is that bias? I don't think so. Again, same thing, right? So I think this is good. So it's not biased, so I'm not going to circle it. Cool? Okay. So now they're going to ask the same thing, but in like reverse. See, this time they're going to say what is not bias. Okay. So we have to kind of like think about that. To estimate the political party distribution in his state, Frank collects data from a large group in his city. So I'm going to ask you the question: is that bias? Yes. Why? Yes. And maybe that city has different values and stuff, right? So just as a quick thing, you could say all of Texas thinks this way, but you go to Austin, keep Austin weird, of course. So you ask Austin, and they're going to get a different view than maybe everywhere else in the entire state, right? So is this bias? Is this bias? Am I going to say yes or no? Yes, bias. So I'm looking for the non-biased ones. So I'm not going to circle it. You see how that works? You got to be careful with it, okay? So it's biased, so I'm not circling it. To estimate the mean number of students in the university, we collect data from a proportionate number of students from each grade level. Okay, so proportionate number from each grade level, that's stratified, by the way, a little bit of everybody. And so they're doing the university, I guess they would do some of the freshmen, some of the sophomore, et cetera, right? So is this bias? You say no or yes? Anybody say yes? It's not bias. So it's not biased. Am I going to? So it's not biased. So I will circle it. Yes, does it make sense? A little bit of everybody seems fine, no problems. But you got to watch out for that little thing at the top. David wants to estimate the mean grade point average for his school, every 25th person. We already saw this one. So this is not bias, right? So I am going to circle it again. Okay. And then finally, Helen wants to estimate the mean number in her city, every 50th person from a list. Again, is that bias? Is that bias? Not bias. So not bias, I will circle it here. Whew. Sometimes I get a little bit confused. That's why I'm putting emphasis on that, okay? Cool? Okay, because they'll try to trick you on the homework. I know it. We'll see that here later. All right, cool. So non-sampling errors caused by factors, this and that. Main thing here that I want to point out, this is all fine, is the word outlier. This is probably the biggest one that we want to talk about. So an outlier is a piece of data that is removed from the rest of them. Just as an example, I'm just going to do an example here. Let's say that I have some numbers. Let's do ages. Okay, let's do ages. So we got like 15, 18, 21, 22, and 85. Yeah, there it was. You know it, right? It like this group's all kind of together, right? But then, whoa, that's like, well, that's an outlier, literally, far outside the range of the others. Does that make sense? Super easy to see, and in fact, us humans are really good at seeing outliers. When we try to translate it into computers and formulas, it's actually kind of difficult, but we can see that pretty easily ourselves. So, after asking 11 people in the residents in her town whether or not they own houses, she found that 36% of residents in her town own houses based on the survey. Why is it misleading? Now, I keep doing her town because sometimes they'll do like state and then town or something weird. I don't know. So they're saying that this is misleading right now. Like, is there an option where it's like, no, this is fine? I don't see an option for that, right? So I need to pick the best option here for why this is bad. Why is this wrong? So what do you think? Give me what you think. D, you think it's insufficient sample size. We only got 11 people, and we're talking about an entire town. Yeah, I know, right? Yeah. So I agree with you. I think that's good. Is there anything else that you can think of? They're they're all residents, but see how she was like, yep, exactly. She's wanting to know for her town, and so she asked people in her town. So I think that's okay. Good question though. That was good. Anything else? So like I agree with you. I think that's true. Again, this is not set in stone, but I call it the magic number 30. The magic number 30. And if you can reach 30, it's basically pretty good. Okay, anything past 30 is just better. Magic number 30. We didn't reach that, did we? We didn't even have 30. So I don't see the outlier. I don't see any calculation errors necessarily, and it's not necessarily biased either. Okay, so yeah, that would be the one. Cool. Okay, awesome. Let's keep cruising. So Howard's collecting data from a random sample of 600 people in his town, asking whether or not they attend church. Based on the results, he got 48%. Oh, whoa. See, I keep underlining it on purpose. Did you see that? You see that? Look at that. Right? It slides right on by and you don't even see it. So we got to watch out. He's asking people in his town, and he says, no, that's going to work for the whole state now. Right? Isn't it like I go into Austin, start asking questions, what do you think about this? And then I go over anywhere else and it's going to be totally different, right? Because keep Austin weird. So, which one would make sense here in this case? The bias, yeah, I think you're right. Yeah, because we're asking the town for the state's purposes. So that doesn't make a lot of sense. See how we got 600 people? That's a lot of people, right? So that part was okay. As far as like outlier, that's pretty interesting. I don't see like a single number that's standing out. That city could be an outlier, but I think it's kind of the bias thing there. So even then, I'm going to put a little tilde just in case, but that's the best thing I got there. All right, this guy. A cell phone company advertises that it has an average of $73. These are the actual values, though. They're saying that there's a problem. So what would you say here? Which one? Gosh, y'all are awesome. That's exactly right. You know how many years I didn't see that? I asked the other professor today. I was like, "Hey, what's up with this question?" She's like, "It's an outlier." I said, "I know that, but why?" And it was because the 9. I was thinking the 73. Silly Chad. Cool. I know, silly little things like that. All right. So they're now going to talk about the ways to ask questions. Like this is a hard break, by the way. And so I just want you to hear this out loud. The number of deaths caused by texting and driving has increased dramatically over the recent years. Did you know that? Are you in favor of laws that restrict texting and driving? See how it sounds like, whoa, people are dying out there, guys. People are dying. Don't you want to save lives? And so it's biased just because you're putting so much emphasis on that ahead of time. Could be the truth, but it's going to cause you to get biased results. Actually, does that make sense? So the goal here is to rewrite it. What would I say here? What would be my true survey question to not be biased? What do y'all think? Just ask the question straight up. Basically, just eliminate this and just ask that, right? Yes. Yes, exactly. Perfect. Here's another one. How many times do you exercise in an average week? Is that bias? No, you're just asking. Okay. Um, yeah. So you could put some other things in there, but yeah, this one's pretty straightforward. I'm going to say that's a check mark. I like that one. Okay, cool. Any questions on that? Okay, pretty straightforward. All right, I think we're finally getting, for me, something more defined. A lot of these are kind of like pick the best one, but these here are you're going to actually find if it's this or that, one or the other, true or false, that kind of stuff. So we got qualitative versus quantitative types of data, and I'm just going to give you the basics here for the Chad version here. Qualitative would be not math, and quantitative is math. There you go. There it is. Ta-da! There's a lot more nitpicky things in there, but that's the Chad version. So the number of flights leaving an airport, would you say that's math or not math? That's math. And so what would I actually call it? Quantitative, yep. Quantitative. You got it. Favorite sport, math or not math? Not math. Therefore, I call it qualitative. You got it. I can't spell, but you get the idea, right? Age, qualitative, quantitative. Quantitative, yep. Quantitative, yep. Telephone number. Mm. Mm. I know, right? It's actually qualitative. And I'm going to give you an example, okay? This one's a tough one. So let's do 254 526 1499. That's the math lab, okay? So then here, 254 526 1494. That's the math offices. So if I subtract these two numbers, I get 5. That's what it is. Math is 5. Right? Like what? That doesn't make sense. So that's why, like, none of that makes sense. That's why it's qualitative. This telephone number is actually kind of like a label or a name. There's no real math there, even if it uses numbers. Social security number. What do you think? Qualitative in light of that, yeah. So age, so I'm 39, and how old are you? You're not going to tell me. Let's just say 20. 20? 20. There we go. So then we have 19 years difference, right? And that's math. And that made sense, right? Okay, cool. So like that would be good math. This is bad math. Very good. Very good. Cool. Here's another one. What about jersey numbers? Like the numbers on a jersey? It's a label, therefore qualitative. Yep, exactly. And so even though it's a number, it could be qualitative, right? Because it's just a label sometimes. Good. Very good. So discrete and continuous are the two other ones here. I'm just going to write these because that's what they want here. Discrete and continuous. How I think about it personally, discrete is like whole numbers, whole numbers. And then continuous is kind of like saying decimals. And that's again not actually correct, but it's rough and it works. Okay. So can you count it on your fingers? 1, 2, 3, 4, 5, that kind of thing. That would be discrete. Okay. If you can't count it on your fingers, then it would be continuous. Okie dokie. So we're going to use those now. Says X represents the number of quarters needed in a parking meter. Can you count that on your fingers? So which one is it going to be? Discrete, yes. Discrete, yep. Okay. So height above the ground when skydiving. Could you count that with your fingers? Not really. And even more so, let me make it funny here. So you're like, oh man, I'm 1,000 feet up in the air, right? And then I jump out of the plane or something. Well, I mean, technically you're at 9,980 feet and 30, or in 3 inches and 6, whatever that would be, right? And it gets down to the point where you could actually start using decimals. Oops, I'm using the wrong decimal place. 998.3 62917 to try to measure it just perfectly would be, yeah, crazy, right? Continuous. You can't use your fingers. Is that making sense? So like even I can say, oh well, I'm 6 foot tall, 6'0". You can count that on the fingers. Not really, because I'm actually 5'11" and 3 8 inches. You know what I mean? It's not exactly what I think every time. The time needed to take an exam. Continuous, because you're like, oh, I got 2 hours for your exam, but you submitted after 1 hour, 59 minutes, 38 seconds, 28 milliseconds. You see, good thing with weight. So I weigh 200 pounds. Oh wait, never mind. It's 198.3821786. Yeah. So that's a good question. Exactly. So continuous. The number of movie tickets. That's definitely discrete. Yep. We're not counting movie tickets like in decimals. It's just you got your ticket or you don't, right? But then you tear it up into little pieces, and no, it's not the point. Cool. Any questions? Okay, not too bad, right? Not too bad. So there's this huge chart over here, and I really like it. It's really cool. We're going to use it. We're going to ask questions about it. I'm going to put little notes on it here. But these 4 levels of measurement are very important. These are actually something that will continue on into your exams. So you'll see this even on the final exam. Okay. So let's talk about it now and go through some examples. These 2 here, and then this is just Chad. Okay. These are generally qualitative, while these 2 here are generally quantitative. Now, we had a huge discussion up there earlier, and you can see here it says qualitative only, but here it says qualitative or quantitative. This particular one, it just rarely happens, but the only quantitative that we came up with was like the pain scale. from the doctor's office. So they're like, hey, what kind of pain scale do you have? 1 through 10. That's the only time we ever saw that. So nominal. Nominal is actually just names and labels. You can see that right here. So like this is the big star there. Nominal means name. Like I think it's Latin. Anyways, nominal. There you go. And so they got some examples here, and it's just any kind of name that you can think of. Just a name. Favorite food, sports, book names, I don't know, all that kind of stuff. Ordinal means a ranking. Ordinal, rank, or like order, order. And so they always have to list it out in a line, in a scale. And you can see right here, the top 5, 1, 2, 3, 4, 5, right? That kind of thing. And so that would be order. Pick your top 3 favorite foods, right? That kind of stuff. Ordinal. Interval, and so both of these again are more numbers centric. Interval and ratio are very similar. I want to make a difference though, okay? Interval can have negatives. And I say negatives because sometimes it could be a little different than that. I have to give a lot of examples for that. While ratio, I guess you could say it like stops at 0. Okay, stops at 0. That's kind of the rough way of seeing the difference between them. So let's talk about these because these are going to be the weird ones, okay? Because I just think numbers, and then all of a sudden they're talking about negatives and zeros and stuff. So, do I have more room? No, I think this will work. Okay. So, things that can have negatives. I know they have these like years right here, but I want to try something else. How about temperature? Temperature in Fahrenheit, like degrees Fahrenheit. Could you have positive degrees Fahrenheit, right? 100-something degrees outside, yeah. Could you have negative? Not here in Texas, but but I mean, it does exist out there, right? It is somewhere. So see how you got like positive and negative. Does it make sense? But here's some other weird things. What about AM, PM? AM, PM. I know that's not technically negative, but it is differentiating between the two. Okay, so it's like afternoon and before noon, essentially. Okay, so that's a positive negative relationship. Here's another one, BC AD. So again, if you kind of think about the timeline, doesn't BC go backwards in time? So you start at 0 and you go negative is kind of like really that way, and then positive is this way. It's kind of weird, but that's at negative in a way, if that makes sense. Maybe. Oh, above sea level, below sea level. Perfect. That's exactly right. I love that. That's a very good one. Positive, negative. Yes. Yes. Cool. And then so the opposite would be something that stops at 0. So something that just like you can't have. Yeah, it's almost like it has to be physical in a way. So apples in a basket, pages in a book, and these are still numeric in a way. I could here. I'll do it right here. Apples in a basket. Pages in a book. Pages in a book. Yes. Ah, you did chemistry. Yes. Yeah. That's a good question. I would say money would have a negative. Like, okay, so here, let's talk about banks for a second. Can your bank allow you to have a negative amount in your account? So, okay, so then if it's a yes, then we got interval because you could have negative, right? But if the bank says, nope, if you ain't got money, it doesn't work, then that would be a ratio suddenly. So, yeah, that's a good question. That's kind of, yeah, it depends on what the situation. Very good. Cool. So, yeah, so what I'm going to do with these next questions is we're going to just, it's ABCD essentially. We're going to like reference back to this. I probably won't scroll every time, but y'all have it, so you can like flip the book kind of thing. Cool. Let's do this. So the masses in grams of a sample of species of fish. And so this is masses. This is kind of like weight. I don't want to say it's weight, but you get the idea. It's how big they are. So this is how big they are. Determine whether it's qualitative or quantitative, and then discrete, continuous, and then also which of these 4, essentially. So first off, is this qualitative or quantitative? Quantitative, it's mathy, right? Numbers, and you can definitely subtract. This fish was bigger than that fish by 3 pounds or whatever it is. Cool. Discrete or continuous? Continuous, yeah, because it could keep going with the decimals. Yep, very good. And so out of these four, which one would you say it would be then? Ratio. Yeah, I definitely agree. And the ratio, because of its weight of a fish, can you have a negative weight on a fish? The fish wouldn't exist, right? So it wouldn't make sense to have a negative weight. Very good. Very good. See, not too bad. Keep scrolling. Is this okay? We good? Okay, keep on cruising. All right. So they have this graph thing on the side here, and so these are years, by the way. I don't know why they didn't do that. So it says, what's the data type of the vertical axis? And by vertical axis, they mean like this thing right here. So without going too crazy, you're just looking at annual income. So what type is annual income from those four that we had earlier? Interval. So could you have a negative income? No. Right. So therefore, we have to use ratio because ratio stops at 0. I do the same thing. So you're okay. I understand. Yep. Ratio stops at 0, and that's why the chart stops at 0. Very good. Cool. Let's keep going. So like they're even saying right here, here's your 4. Pick which one. So length of the song in an MP3 player. Ratio, because if the song length was negative, it wouldn't be a song anymore, right? So yes, ratio. Very good. How long you wait in an amusement park? Yep, it could be 0. You could walk right in, or you have to wait. But it's not like negative where you can like teleport in. I guess. I don't know. Huh? Leave? You just leave. Negative. I'm done here. um, 3 political parties. They're saying like just this right here. What would you classify this as? Nominal, I would say. They didn't put a particular ranking on it. They just kind of listed them out, and they're all just names. So nominal. Yep, nominal, just names. The number of years at a job. Ratio sounds pretty good. I like ratio as well. Again, if you had 0 years at the job, you wouldn't have had a job. Does that make sense? Top 5 books. What would this be? Ordinal indeed. You got it. Ordinal. Order. You can see the ranking, right? First, second, third, fourth. Yep. Very good. Telephone numbers. That's a good question. In a phone book. So, okay, in a phone book, they're not classified by the numbers, they're classified by the names, aren't they? And so, does the number mean like, one number versus another number? It would be nominal, I think. Yeah. So this is just it's just a label that's attached to the name. Now, the names themselves, now that I'm thinking about it, right? Like you got all the A's, all the B's, all the C's. That might be a ranking, but they're not asking about that because the A's start at the top, B's and then C's and then D's. So I don't know though. I would say this thing here is nominal. Year of birth. And be careful. This is the stress of it. Year. What would it be? It's interval indeed. It's interval. And I'll tell you why here. Here, 2000 and stuff, we're all born into 2019 something or others, right? What about Julius Caesar? Right? BC, negative. Yeah, I know, right? So, yeah, that's that BC AD stuff. And they're not talking about us. Could be Julius Caesar. So there you go. Okay, cool. Temperatures. Interval. Yep. Especially in Colorado, you can have positive and negative there. Not like it's here. It's positive. Cool. Y'all getting the feeling of it? Awesome. Good? Good. Okay, cool. Is that it? That's it. So I want to do the homework with you. I mean, I know that we got, oh man, we almost got a whole hour. I want to go through the homework. I want to show you what the homework looks like. Maybe there's a question or two that we haven't seen yet from this workbook. I just want to see what's going on with it. So, and this is a good opportunity to kind of just keep learning about it. And so here in Blackboard, just to kind of like recap what we're doing there, if you click on Newton Alta, they have the coursework. There it is. And then from here on, this is the actual stuff that you'll be taking in this class. So this is all the homeworks, the quizzes, exams, all in this one folder. This is going to be our practice review stuff. We'll do that together when we get closer to an exam. I'm going to start the homework. And this is how you register for the class on Newton Alta. You literally just click on it, and it should just start the registration process. Okay, it'll ask for access code. You can say temporary access, all that kind of stuff. So there we go. Launch and view as a student. All right. So my goal is to get a 100% on this, and y'all are going to help me. Oh yes, you're going to help me. Okay, start calling it out here. So Raymond wants to estimate the percentage of parents that use cloth diapers. Let me tell you, it's kind of gross. We tried it. Moving on. He asks randomly select a group of 200 parents whether or not they do this. What is the data? And I almost feel like I need to go back to the workbook to see what do they mean by data, right? But let's go through and see here. The percentage of all parents that use cloth diapers. 200 people surveyed. I think that's like the sample, isn't it? All parents that use cloth diapers, the percentage of surveyed parents that use cloth diapers, or specific yes, no's. What's the data? What would you actually have a collection of that you have to start looking at? Ooh, I like it. Lots of different answers. I'm going to say this guy. I'm going to guess. Because the data itself is if y'all have ever seen data in Excel, it's just a whole bunch of yeses and nos, and then you're going to count how many yeses and nos to get the percentage. That would be the statistics. So right here, this is like statistics and stuff, math, I guess. Cool. Okay. So watch out, but okay, if you get it wrong, no problem. You'll see it again in a few minutes, right? That's just how this homework works. You just keep on doing it until you get it right, and you'll be fine. Okay. Good. Even then, when you get it right or wrong, there's still all this definition stuff down here. So it's a set of observations. That's a yes or no. Continue. Okay, so we want to estimate the mean number of siblings for each student in her school. She records the number of siblings for each of the 200 selected students. What is the data? What's the data? What do you think? Specific numbers? Yeah, like each single number got your height. Was it height, right? No, number of siblings. Your siblings and your siblings and your siblings and your siblings, your siblings. There's a whole big list of siblings, and then after that, we'll find an average and stuff. Let's try this. Let's try this. All right, cool. Yep. So it's the actual data that you're getting, like the survey results. You haven't even done any math with it yet. Good? Keep cruising. Look, what's our percentage at? We're at 13% already. We just got started. When considering different sampling methods, stratified, what did I say stratified was? A little bit of everybody, right? So a little bit of everybody. Divide the population into groups, simple random this to find a proportionate number of individuals from each group. Sounds pretty good. Sounds pretty good. List the number of people in population, simple random sampling, let K, that's a key to something else. That's systematic right there. Systematic all day long. Identify individuals who are easily accessible right outside Walmart. It's convenience, isn't it? And then finally, use random sampling to select set of groups, each person from that group. Everybody in this area code. Everybody with this zip code. That would be cluster. So blah, 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 this dude. Cool? Is that okay? So I'm maybe talking too much when we could have just clicked the top. But I just wanted to make sure we clarify a little bit there, Here's another one. Okay, so they're saying cluster, right? Cluster. Which one for cluster? A, B, C, or D? A? Yep, groups, clusters, and every person in that group. So everybody with this area code, everybody with the last name starting with A, everybody who has this zip code thing. Yep, exactly. Cool. Notice one other thing before we keep going. See how there's like these little tabs up here? And we have halfway done with this current objective. They keep swapping them out back and forth. So this is like the overall percentage. That's what your grade is. And then this is kind of like saying, hey, probably got like 2 more questions like that. Okay, cool. So we want to estimate the percentage of homeowners who own at least one dog. Survey 100 people. Determine if they own dogs. What's the parameter? Parameter. So that's math, but for what? Population. It's for the population. Okay, so we want the math for the population. Which one? A, B, C, D, E. C? C? Yeah, so like percentage for sure, that's math, right? But then all homeowners versus just these surveyed ones. So yeah, that's the population, all. All, every, each, math. There it is. Let's try it. Cool. See how I'm like decoding it, right? We're trying to find those keywords. The whole class is not going to be this way. Trust me. We will do MATH one day, but just not yet. It'll be fine. Okay. Estimate the mean height in his college. Records 25 from college. What's the parameter? There it is. Math for the population. So which one? B. B. Yep. Mean. That's average, right? Math. So we got math for population. There it is. Keywords. Yeah. B. Let's try that. B. Yeah. Look at that. And so we're done with one of them. They're going to cycle through. We'll just have like a couple more questions left, but you can see we're at 38% already. That means we, as in all of us, right? And you're like, no, I'm going to have to go back and do this on my own. Okay, so different sampling methods, true or false. Clustering would divide into groups. Use this proportionate. Whoa, whoa, whoa. That's not cluster, is it? What would that actually be? Stratified, yep. So this would be a false. Okay, cool. I like that. Continue. Oh, I like this. To study the average blood pressure in all people in her state, she samples a population by dividing residents into 9 different towns. Then she collects all the data from all of the towns. Cluster. I like that because you're saying everybody in this town, right? Doesn't matter, but it's everyone in this town. You're physically connected. You probably have nothing to do with blood pressure between one another, right? I mean, it's just a town, right? So yeah, cluster. But here's one thing I want to do before I want to keep going, because I know that's going to be right. We have other buttons down here. Yeah. So like, okay, instructor cheat. That's for me. So if I ever get confused, I could just hit that button. Woohoo! I got the answer. And I'll show you that in the next one here in a second. But more instruction. I want to click this instead. Okay. Let's say I just don't know what's going on with this guy. More instruction. And they're like, hey, are you sure? Yeah. Yeah, I'm sure. And so they got like videos, they got all this text, and they got this stuff, which I think that's the most important right there. So it gives you more stuff when you click it. So continue, and then it asks you a very similar question. So I'm going to say, from here, from all this, let's go and answer this one now. Okay. So wants to select the average number of AP classes, decides randomly to select this, and uses all the students in those 6. Which one? Yep, I think cluster once again. Let's try the cluster. Yep, that's cool. But I was purposely just wanting to see what that would be like, right? That feedback thing, or I'm sorry, not feedback. More instruction, right? That's what it was. There's a feedback button. We're going to do that too. Oh, here we go again. Okay. Wants to inspect the cleanliness in hotel rooms. 10 floors in a hotel. Each has 20. From each floor, she selects 2 rooms. Come on, tell me. So she's getting 2 from this floor, 2 from this floor, 2 from that floor. Stratified, a little bit of everything, right? A little bit of everything. Stratified. Yep, cool. And I'm even completing my objectives by doing that more stuff. So I probably have to do a little bit more work to get it, but you can still even get your homework done there. If you scroll back up to the top, we've got even more now. We're at 50%. Cool. Okay, so there's another button. Here's another one, feedback. And so if anything ever looks wrong, and let me tell you, Newton sometimes is wrong. So you can click feedback, and then it got a lot of options. And so I'm going to do, I have an idea. Oh man, this is hilarious. I think that was just awesome. But I want more. So much more. Submit. So someone's gonna read that in like New York or something. I don't know. And they always send me back emails from this, and they're like, "Professor Burrow, what were you meaning by this?" I'm teasing them real bad. But sometimes there are wrong things, and I tell them, and they're just like, "Well, we investigated this, blah blah blah," and normally they're just trying to defend themselves, but we can at least fight back. Okay, good. So y'all can do the same thing too. You can tease them and stuff. A study was performed with a random sample of 5 people in a certain city. What population would be appropriate for the study? Data collection, so it did not use bias. Okay, so they're saying, what population should we have? Is that what they're saying? Random sample of 5 people in a certain city. What's the population? The city, yeah, I would say so. Everyone on Earth. 5 people decide everything on Earth. So yeah, conclusions restricted only to the city. That sounds pretty good. No, that's too much. Still too much. Only to the sample. I think that's kind of silly. I mean, it kind of doesn't make sense. You're like, out of 5 people, it's like 4 to 5, dentists per crest. It's like, but there's only 5 dentists. So conclusions about people in any city. Woo, that's not the case. It's just this city. So yeah, this city. What? Okay, hold on. Why? I want to know why. Oh, look, because it's too small. So what? Here, I've actually never seen this problem in my life. Sometimes they're trying to trick us. Isn't the sample size too small? We already knew that, right? I mean, I would have thought that anyways. It's not at least 30. But because it's too small, they're saying, in a way, you can't do anything with that. And their way to get around it is to say stuff like, oh, well, you can only say things about the sample. But what it's trying to say, if I could rewrite that, I would say it just doesn't work in general. So they're kind of making a weird statement there, okay? I don't like that one. Sorry. But I'm still at 52%. And I'm going to keep cruising. So that's okay. And then it happens. I get stuff wrong. Maybe they're just being way too weird. Let's keep going. Statistics students obtain a sample surveying all students in the class. Hey, look at that right there. What group can the results be generalized to? So what do you think? A, B, C, or D? B? So it should be applied to any college? No. All the students at the college? Only to the sample. That's what we had last time. And then apply to all people. I don't think that's right. So, this one is this one's highly misleading. How many people are in this class? That's the question, isn't it? And so if it's a class of our size, we're still not 30 yet. So, yeah, I'm going to try. Do you agree with me? If I try that it only applies to this, I'm going to probably get it wrong, but let's try. Oh, yes, we got it right. Woo. Okay. So yeah, okay, let's talk about why. Let's see what they say. The sample that was obtained was not like representative of this. Okay, yeah, they're kind of saying what we were saying. It could be a small class. Cool? Whew, okay, we got that one done. What am I at now? 58%. We had seen this one on the workbook. So scientists about the effects of soil quality Would experimental or observational be better for soil quality? What do you think? Should we just look at the soil, or should we experiment with the soil? Experiment. Yeah, we got fertilizer. Yep, yep. Okay, so it's going to be A or C. Okay, so we got crop quality is controlled, or the soil quality is controlled. Yep, because we can add fertilizer, right? Yeah, there we go. Very good, very good. Cool. Okay. In a study to add new feature to a program, they have two categories: the survey, observational, or this. If it's an experiment, let's control this. Okay. Add a new feature. Programmer introduces two categories in the survey. I guess they're just asking if you're male or female or something like that. I don't really know. So is the study observational or experimental? Yeah, I think so, because that's, you can't like experiment like that. I don't know. We're gonna just do observational. And they're just submitting that on a survey, right? We're not trying to change it anyway. Remember, experiment, I'm taking sugar and throwing it on the ant pile, see what happens, right? I'm changing something. And there's nothing to change here. You're just asking a survey. Good. Okay, energy drink wants to find out effects of different amounts of this and that for rowers. Yeah. Would an experiment or observation be better? Experiment. You're gonna hype them up on caffeine, see how fast they can go. I would say yes. And then you can control the amount of drink consumed, right? Okay. Yep. Cool. Wow! I feel like rowing. Yeah. Okay. Wants to estimate the effects of Facebook on happiness with the experiment or observational. Interesting. Can you experiment with something like this? Yes, you can give them a lot of Facebook. How happy are you now? In the real world, we're probably just observing, right? Just going to say that. So observational. It's not possible to control happiness. It is not possible to control Facebook. Maybe it is experimental. Because we can technically control the amount of Facebook someone would have, right? Just shut the internet off. But we can't control happiness. At least I can tell you that much. Okay. So maybe we can control the amount of Facebook time, right? Cut the internet off. Okay. Yep. And see, sometimes I'm questioning. I'm like, and then it's that tense moment. You ever have that tense moment? You're gonna have it a lot in this class. Let me tell you. Click it. You're like. Sometimes it even hits the loading for a while, and you're like really panicking for a bit. Yeah, I've been there. Okay. Consumer research company determines certain this new refrigerator is more efficient than the older one. We had this one on the workbook, didn't we? Now we can actually prove if it was right or wrong. And so I think that we had done the 10% less. Was that the one we had chosen yesterday or last time? I think so. Let's hit it. Oh, good. Okay, good. All right. Cool. How close are we? 92%? Should we just keep going or just shut it down now? Gosh, of course. Right? Consumer research, interested in determining amount of new refrigerator, decides to investigate the claim, uses 10% this and that. What data collection method is appropriate? So how are they collecting data? Companies should obtain random samples from each model and measure electricity. Okay. Place them in similar conditions, fill them with the same amount of water bottles, and then monitor over a month. That sounds better, in my opinion, because once you put different amounts of this and that, it might change how often it cools. Should get a random sample of a new model, place them in all similar conditions. Oh, do you see the difference? Look, only the new ones? No, we want each of them, right? Like, so far, that's my favorite. Obtain a new model and old model, place them in the same room, fill them with this, monitor this and that. What's the difference between this one and the top one here? Top one has what? Oh, it has more samples of each rather than just literally one and then another. Gotcha. Yeah. Okay, there we go. Cool. Gotcha. See those keywords, And we're done. So sometimes they do confetti and stuff. Woohoo, you did it! Yes, thank you, thank you, thank you. Let's do the next one. And since we still have time, we're going to keep cruising. So what I'm going to do is I'm going to go back to, not that. Let's like back up out of that. Here, 1.2. And after this, should we just call it a day? I mean, I could definitely keep going. I don't mind. Because we're going to hit up the MATH here pretty soon. Select all the following scenarios that are bias. Okay, so we just did that. That was like one of the first questions we did today. Kelly wants to estimate mean number of calories consumed. She collects data from people eating breakfast. Is that bias? Oh yeah, because like I'm munching down on my Cheerios, bro. Leave me alone. And maybe somebody else wants their grapefruit. So calories would be different for that. So is that bias? Is that bias? Yes. So I click it. Does it make sense? Okay, keep cruising. Estimate background, different cities, collects data from 1,000 people in selected city. Is that bias? 1,000 people randomly generated? I don't think that's bias. Keep going. Estimate the mean shopping, collect data every 10th person. Is that bias? I don't think so. Oh, you know what? It's so subtle. It's so subtle that is bias. You want to see how subtle it is? Look, watch this. Yep, ask about clothes in a clothing store. Yep. So that's bias. That one's subtly biased. Homer wants to estimate mean number at his school, every 25th person in the school. Is that bias? I'm going to say no. Submit. Okay. Cool. Awesome. Yep, little things like that. After asking 11 randomly selected residents whether or not they own houses, she says that 36% of residents own houses. What's wrong here? Yeah, the sample size, only 11 people. Sample size not sufficient, for sure. For sure. Yep, we just talked about that. Okay, cool. Again, we're looking for bias. Again, sometimes they'll say like not bias. We got to watch out for that. So wants to estimate the mean number of students, collects data, randomly selected person within her classroom. Is that bias? Wanting to find out the heights of all CTC students. I'm just going to ask y'all though. Okay, is that bias? Okay. I mean, I could be asking the basketball team again, right? So I would say that might be bias. We're going to see. Estimate the mean number of clothes and clothing store. We just saw this one. Is that bias? Yep, keep going. The mean number of people in university, proportionate number of students from each grade. That's stratified. So it should be okay. So is that bias? No. So don't click it. And finally, political party distribution collects data large group from residents in the. Oh, whoa. You see it? State and city. See it? Keep Austin weird. So is that bias? Yeah, that's bias. Okay. Y'all have heard like keep Austin weird, right? Okay. I'm just making sure that makes sense to y'all, I'm not trying to keep Austin weird. I don't even go to Austin, but my point is that we've heard that, right? And it rings in our brains. So we're collecting data about a big random sample in a school, whether or not they're reading one book per month. Okay, she got 35% of all state schools read that. So she went to her school district, and she says now for all the state schools. Yeah, that seems wrong. So which one is it? You say bias? Okay. Could hers be an outlier? So that's also another option, okay? But the sample size is good, and I don't think there's necessarily a wrong math, okay? So yeah, it's either going to be this or that, and I'm going to click bias, and we're going to see. Here we go. Okay. So yeah, I want to read a bit more, because I often think outlier because it could be an outlier. But here, let me see. Individuals included in the sample are not represented in the entire population. Okay, so that's it. So it's biased because we're only asking some people, I guess. Okay, I like that. That's fine. Good. Keep cruising. Notice? Did you see it now? You see it? Look, not bias. You got to watch out for those little things, right? But we already saw that on the workbook here. So wants to estimate the mean number for salary for professors. Low. So she collects data by recording salaries of all professors from 12 different departments. Is that bias? Is that bias? I think it's not bias, so I'm going to click it, because again, we're looking for not bias, I think. Okay. Estimate political party distribution, large group from city, state and city. Is that bias? That's bias, so I don't click it. Yeah. Justin wants to estimate the mean number. Oh, the mean weight of people, so he goes right outside the fitness club. Ugh! That's bias, so I don't click it. Right, so I don't click it. And then finally, estimate ratios. We collect every 50th person, the residents of that city. Bias? Bias? Not bias? Not bias. I will click it this time. Okay, cool. All right. Okay, cool. Keep cruising. Which of the following scenarios contain biased samples? Oh, here we go again. We're almost done. See, if you ever get bored and you're like, man, how many of these will there be? It's showing you right here there's only one more, okay? We're almost there. So we're looking for bias. Background, 1,000. Oh, here we go. For the town. Town and town. So I think we're okay there, right? So that's not bias. We're going to keep it. Political party distribution, state, city. Bias? It's like we already seen all this, right? Cheerios at the breakfast table. Is that bias? Yes. Wait at a fitness club. Bias. Yes. Submit. Okay. Okay. Good. We're done. Whew. All right. Let's keep going. We got this. We got this, guys. Look. What are we sitting at? What are we sitting at? 38%. Almost there, guys. I won't be doing this all the time, right? I just wanted to, like, we had some time. I want to show you what it looks like. And this is, we're doing your homework, right? Howard collect data from 600 people. That's a whole lot in his town. Whether or not they attend church, he says that now in his state. Town, state. Problem, right? So what is this? Bias. Yep, bias. Yep, very good. See, y'all are just rocking this thing. This is good. Okay, we got 600 people. That's pretty good. Whether or not they exercise 30 minutes a day, 53% in the nation. University nation. Is that a good thing? No. What is this then? Bias again. Yep, bias. Yep, exactly. Confetti! Woohoo! I know. Feels so good. Okay. This is some fun stuff here. Restaurant surveys its patrons to pick their favorite menu item. Which one? Favorite menu item. Pizza. What is it? Nominal. Yep. Just a name. Pizza. Yep. Cool. Okay. Which is the best for qualitative? So qualitative is not math, right? Not math. So numeric character, probably not. A type of quantitative, no. Quantitative, no. Attribute who's a label. There it is. Names, labels, right? Okay, cool. I'd never seen that question before. Given Janet is collecting data on favorite sports team, what kind of data? Favorite sports team. Qualitative. Yep. Just the name. You're not even ranking them yet. Okay, zoologist. Birth weight of each cub. Birth weight. Ratio, because you can have like 0 birth weight would be not a cub at all, right? So yes. Very good. Very good. Man, look at this. Look at this. We're already at 75. This is sweet. What type of quantitative data is used? Oh, wait, that is the result of measuring. Continuous measuring. Oh, yeah. I'm seeing it. Because this one's the whole numbers. That doesn't make sense. And this one here, this doesn't make sense in what I think. So here, let's pause for a second. This is one of those opportunities where I feel I'm going to use the workbook. Okay, so I'm going to go back to the workbook, and I'm going to look specifically at the actual definition of quantitative, not just Chad's definition. I want to see what they have, right? Oh, here it is. Quantitative, numeric measurements or counts. Okay, no. Okay, let's go back to continuous. Continuous, right here. Uncountable number of possible outcomes. Interval on a number line. Uncountable. What type of quantitative data is a result from measuring? I guess, okay, continuous. Let's try it. Yeah, okay. Where's that word measuring over here, right? Shouldn't we have like measuring somewhere around here? Do you see measuring? Oh. Well, there's measurement right there, but we already knew it was quantitative. Okay, I don't know. Whatever you want to call it. Is that okay? Okay, I know that we knew, but I was just making sure. Okay, cool. So, collecting data. Number of books student read each year. What type of data? Number of books. Discrete, because you can count them on your finger, right? You either read the whole book or you didn't, right? 1, 2, 3, 4, 5 books. There it is. Done. Discrete. Okay, we're almost there. What is this? We're at 88. Market research finds the price of several brands of fabric softener. So the price, what would that be? Ratio, because well, they could be giving it away for free, 0, but they could also be paying you to take it, right? Negative. I'm just joking. I know. Mother keeps track of the time baby's going to wake up each morning. Whoa. Right here, that's important. Time. So she's keeping track of the time when her baby wakes up, right? So you're thinking ratio? Is that what y'all are thinking? Interval. I'm thinking interval too, because it's not like, oh, he slept for 2 hours, right? And it's not even that he slept for like 1 hour and 58 minutes and all that kind of stuff. It's that he woke up at 8 a.m. and he woke up at 3 p.m., right? AM, PM. Does that make sense? So yeah, interval. That's my guess too. Okay. But it was a little bit off, in my opinion, because they said in the morning, which means it has to be AM. But then again, people be waking up at 3 p.m. It's like, yeah, I'm having a great morning. Especially babies. All right, there we go. Yay! All right, cool. I would love to keep going, but I don't think that y'all want me to keep going. So what interest level do we have here? Nominal or ratio? I'm playing. So are y'all okay with getting out a little early today? Is that okay? And we're going to start chapter 2 on Tuesday. Good? Any questions? Good? Okay, thank you guys. See y'all later.